So hello guys, welcome back to our channel. So today we are going to solve the LeetCode problem 1727. So today is March 17. So in here we are going to solve this problem. So let's dive on to this problem. So they have given this problem is largest submatrix with rearrangements. So here you are given a binary matrix with zeros and ones, and you are allowed to rearrange the column in any order you want. So your goal is to find the arrangement that produces the largest all ones submatrix and return its area. So at the first glance, so the freedom to rearrange sound like it makes the problem harder. And there are infinite possible arrangements, so which one is optimal? So but here's the thing, so that the freedom is actually a gift that we can use it. So it means we can evaluate columns independently. So we have sort them by the single criterion, and the optimal arrangement reveals itself automatically. So today we see how to do that. So this problem is LeetCode 1727, the largest submatrix with the arrangements. So it is a medium problem, and so we can use greedy and sorting method. So as you can see here, so they are given greedy and sorting method. So using this we can solve it. So we'll cover the full problem and build the intuition from the scratch and explain every line of C++ code and dry run for the all examples and go through every common mistakes. So let's get into the problem statement. So here you are given a binary matrix and a matrix of size m cross n, and you are allowed to rearrange the column of the matrix in the order, in any order. So we have to return the area of the largest submatrix within the matrix where every element of the submatrix is 1. So after reordering the columns optimally. So this is what they have given. So this is the first example. So the first key point is the submatrix is continuous rectangular region. So after rearranging the column, we want the largest rectangle made entirely of only ones. So in this column, so initially it is 0, 0, 1, 1, 1 like that. So 0, 0, 1, 1, 1, 1 and 1, 0, 1. So as you can see, the 3 is the largest one, but here as you can see, it is in a single column. So if you take this, it is 3. So but if you rearrange this column, you will get the size of 4. So this is what they want. So the largest submatrix of the ones in the, and it is, they have bolded here. So this is the size, the area is 4. So as you can see here, if you rearrange this column, so it will become triple ones. So the area is 3. So you can rearrange the columns as shown as here, and you can arrange however you want. So for this one, so let's open the notepad. So here it is 1, 1 and 0, or else we can make it as 1, 1, 0, 1, 0, 1. So this is the matrix. So if you move this column here and as well as this column here, there is nothing will change. Okay, because it still have 2 as the maximum value. So if you still move that, these 2 will be continuous, and if you still move that, these 2 will be continuous. So we must have there is no possible other ways. There is the 1 will cover the entire row. So that time the value is still 2. So 2 is the output. So let's try to solve this problem using understanding these 3 examples. So before that we see the constraints of this problem. So M is nothing but the matrix length, N is for number of rows and N is for number of columns. And here they have give the M multiplied by N is the number of rows and columns multiplied multiplied by n, and m is the total elements present in the grid. So it is up to the value of 10 power 5. So they have given the element as either 1 or 0. So using this we are going to solve it. So let's build the idea for solving this problem. So for any submatrix and to be all ones, so each column is included must have a consecutive runs of 1. So that spans the same rows as every other columns. So the question is, for a given bottom row, how tall can each column be? So for example, we define the height. So here, so the we define the height is nothing but the height of I and width is equals to the number of consecutive ones in column J and ending at the row column I. So if the matrix I and J is 0, the height is 0. So if the matrix of I and J is 1, so the height is, we can say the previous element I minus 1, the previous row, and it will be added by 1. So for example, let's see. So the original array would be like 0, 0, 1, and after that 1, 1, 1, and 1, 0, 1. So this is the original grid they have given. So after we manipulate this value, the height will be transformed. So that time the height transformation is 0, 0, 1, because the height is, we are decrementing the value with what we have right now. So 0, 0, 1 and 1, 1 and 2, and 2 will be come here, and 0 and 2. So this is the first one, and this is the second one, and this is the third one. So like that it is offering. So if the height of I and J means 2, the column I have 2 consecutive ones. So there are 2 consecutive ones, and this is, there are 3 consecutive ones. Like that it will have the value here. So this is how this is being stored. So using this we can solve the problem. So why we have to sort each array, and it is works. So the given the heights of all columns at the row I, so what is the largest all ones submatrix with the bottom at the row of current value I? So if we sort the heights in the descending order, so the problems will becomes trivial. So for the kth largest highest in the sorted row, we have to call it as height of the kth value. So it means there are at least k columns with the height that is greater than or equals to h of k. So we can form a submatrix of height and with k, which is have the greater area than the current value. So why does the descending sorting give the optimal? So because sorting, let us use the greedy argument. So the kth column in sorted order in the bottom. So the shortest of the kth value, so we have include all of the k value with the minimum height. So we try every k from 1 to n. So what we are doing, we will approach from greater value to lesser value. So using that, if any value, the current k value is greater than, after then every value is also greater value. So using that, we can solve this problem. So this is where the greedy approach is being used. So we'll have to sort it in the descending order. So the greedy correctness argument for all ones is submatrix of with W and height h with the bottom at the row 1. So all columns must have the height that should be greater than or equals to the current height. So this means the current height value, which is the top position that is sorted in the row. So if it is greater than the value, so all other before values will also be greater value, because the current value is also greater than value. So let us see the algorithm how to approach it. So for approaching it, so for each cell I and j, so for matrix, the current element, let's say the matrix of I and j is equals to 1. And if I is greater than 0, that means it is not the first element. So I is greater than 0. So that we can set the matrix and we can substitute the matrix of I minus 1. We can set the current matrix with the previous element. So that is I minus 1 and j plus 1. Okay, we'll add it the previous element with 1. So otherwise we can leave it at is if it is 0 or 1 for row 0. So this computes the column heights in the place. So for each row we have to sort the row in descending order. So for each position in the j, we can compute it with the value of global maximization. So using this, we can retrieve the global maximum value. So which is the output that is currently being stored. So let us write the code using this approach. So they have asked for integer return value and they have given a 2D matrix as the input. So now let us create three values. So for m is the matrix size. So in m is matrix size and n is matrix of element size. Matrix of 0 dot size. So we got m and n. So finally a variable to store the final answer. Answer is 0. So the first step is we have to compute the column heights. So for that we'll iterate through it. So for I is 1 and I less than m and I plus plus. For in j is 0, j less than. So now j is 0 and j less than n and j plus plus. So we have created two loops to iterate over it and we have to calculate the height. So here we have to check if my current element, so that is matrix of I and j is equals to 1. So if it is 1, the previous element, so the previous row element will be added by 1. Okay, so using that only we have changing the column. So as you can see from this row, we have previously drawn. So it is 1, 2 and 3. So here it is 0, 1 and 0, 0, 1 and 2. So now we have to add it to the current value. So matrix of current value is equals to matrix of I minus 1 and j will be added by 1. So using this previous value, we can count how many ones are present in the current column using this method. So after calculating these values, now we have to sort each row descending value, each row by descending value. So for that, for in I is 0 and I less than m and I plus plus. Okay, so now we have to sort it. So sort, so matrix dot begin matrix. So using that, we are going to sort it with the first value, that is row value. So matrix of I dot begin and matrix of I dot end. So next one is, it is sorting in a ascending order. For make it as sorting in the descending order, we have to use greater and in. So after this greater than in, we have to use a parenthesis. So after that, you can just use it. So now after sorting, we'll have to iterate through it. So for int j is 0 and j less than n and j plus plus. So now here my matrix of ing. So that means if when I reach my current element as the value 0, okay, so that time there is no point in continuing. We can simply break it. Okay, so or else the answer is the maximum of the current answer, or else the matrix of the current element I and j is multiplied by the value j plus 1. So we can give parenthesis here. So after adding, we can calculate this value. So this j for 1 is, it is 0 index. So that's why we are using 1 indexing here, and we will be multiplying the current element with the value. So using that, we can find the area of the element. So when it reaches 3, so it will become like 3 cross 3, it will become 9. So that's how we will be calculating the value. So finally, we have to return the answer. So after the for loop, return answer. Okay, it is just simple as that. So first, we have to calculate the number of ones with the continuous ones in the ranking system. So if it is continuous, we can just simply add it. So if not, we can just leave it as it is there. So there is no need for that. So if m is the number of rows and n is the number of columns. So and the answer is, we have to track the global maximum area. And initially it is initialized with 0. And if the matrix has no ones at all, we return 0. So which is also the correct, that we have given initialized with 0. So there is no need to worry for that. So the loop is started here, and we declared I is 1 because we don't need to check for the first row. The row 0 stays unchanged, since even if all the values are 1, and there is no row above it. So for row is 1 and it is beyond it. So if the current cell is 1, its height is 1 more than the cell that is previously above there. So if the current cell is 0, we leave it as 0. So then the run of once in broken, the height is resets to 0. So this is the computed in place, and we modify the matrix directly rather than allocating the space of the height array. So this saves the space, and it is a valid because we only look into the previous row, that is row of I minus 1. So when computing the row of I, and we process row top to bottom. So next one is sorting each row in the descending order. So for descending order, here we have iterating through the array. Next, we are sorting the current row, and it is in the current row, but we are sorting in a descending order using this greater int. So here the greater int is a built-in comparator and it forms a functional header, and it is already included with this header that is pre-defaultly given in this loop. So there is no need to worry about that. That is bit/standard C++.h. So in most commonly we will be using it in competitive programming. So in a clean code base, it will include functional, that is explicitly. So at sorted position, here we are using the next one. So the J current elements. So the current element position is 0 index. So the matrix of I plus j. So that time we have to use j plus 1 because it is being 0 index. So that is the tallest height. So if we include j plus 1 columns and the tallest j plus 1, so the minimum height among them is the matrix. So since the row is sorted descending, so there is the maximum rectangle area using it j plus 1. So the column of matrix of I and j, and it is multiplied by j plus 1. Okay, it is nothing but the current value and it is multiplied by the total height. So let us see the full dry run of the sample program here. So first, so this is the matrix. So here it is initially 0, 0 and 1. And 1 and 1 and 1. So 1, 0 and 1. So this is the matrix. So now in this matrix, this is they have given. So first what we are doing, so we are going to iterate through it from this row and change the value of the current ones. So first what we have to do, we have to transform the array. So for that we'll leave this array, and when we come here it is 1, the previous plus 1, 0 plus 1 is 1, and this is 1, 0 plus 1 is 1, and this is 1. So 1 plus 1 is will become 2. So now this element comes, so it is 1. So 1 plus 1 is 2. This element is 0, we skip it. This is 1. So 2 plus 1 will become 3. So this is how the array is being transformed. So after transforming this row, so we have to move on to the next step. We have to sort it in the descending order and scan the each row. So now for the row of 0, that is nothing but the first row. So if it is being sorted, so it is 0, 0, 1. If it is sorted, so now it will become 1, 0 and 0. So now j is 0. So if j is 0 and the height is 1, so we have to multiply the area by. So the value is 2 and it is multiplied by 1. So sorry, it's 1 and 1. So 1 is multiplied by 1. It will become 1. So the answer is 1. So it will be multiplied and it will check if it is greater than the value or not. So 1 is greater value, so it will do. So once it reaches 0, we can break it and move on to the next one. So initially this is the height. So height is 1. Height is 1. And the area will be multiplied by with the value of 1. So it is 1. Okay, the j is 0. So 0 plus 1 is 1. So height is also 1. So it will be multiplied and the answer is 1. So answer is 1. So that is nothing but the maximum value. So the next one is when j will become 1. So that time what is happening? It is 0. So it will break out of the condition. So now it is row 2. So when we reach row, it is row 1 for the 0 index. So when we reaches this row, we have to sort it. So when we sort it, it will become 2, 1 and 1. So initially the j is 0. So j is 0 and currently the height is 2. H is 2 and it is multiplied by the value that is 0 plus 1. So 1, the area is 2. So currently the answer 2 and 1, the 2 is the greater value. So answer will become, so j is currently 1. Now the height is 1 and it is multiplied by 1 plus 2, that is 2. 1 plus 1 is 2 and it will become again 2. So answer still remains as 2. So then we have to move to the next one. So that is j is 2 and height is 1. So here the height is 1 and it is multiplied by 2 plus 1, that is 3. So 3 will become, so answer is 3 currently, because it comparably 2 and 3, 3 is the greater value. So 3 will be stored in the answer. So we have to move to the next row. So that is the row 2. So when you reach it, you will see 3, 2 and 0. So j is 0. So 3 is multiplied by 1. You will get 3 as the output. And answer is still 3. So next j is 1. So now the height is 2 and 2 is multiplied by j plus 1. So j is 1 and it is 2. 2 times of 2 is 4. The answer is 4. And when j is equals to 2, the value is 0. So we can stop there itself. The final answer is 4. 4 is being printed as the output. So this is how we are solving this problem using this method. So let's see the complexity of this problem. So here, first for the height computation, it will become, for iterating through the entire grid, it will become m multiplied by n. So after that, with every visit, we have to visit the every cells one and starting the array. So now, using the sorting method, so per row, it will become log n. So it is n log n. So we already have this n. So we can simply use log n. So the time complexity is big O of m multiplied by n and multiplied by n log n. So that is nothing but log n. So the time complexity of this problem is m multiplied by n and log n. So with up to the 10 to the power of 5, it can solve this case. So this is within the limits. So next one is space complexity. So for the space complexity, we didn't use anything other than this given array or the grid. So the space complexity is a constant space big O of 1. So that is nothing but big O of m multiplied by n multiplied by log n. So now let's try to submit this problem. So let's submit it. Let's check all the test cases they have given. So that all the test cases have been passed and the problem is being solved. So let's see what are the common mistakes people would do in this problem. So first one is, instead of checking from the first row, people would start from the 0th row. So which is one of the biggest mistake, and they would forget to give condition as well. So 5 is greater than 0 like that. So that time the value will be entirely changed and the output will behave as a crash and there will be no output. So next one is, we have sorted in a descending order, but people would forget and do it in a ascending order. So sorting ascending puts the smallest heights first. So then j plus 1 columns, that means with the minimum height, matrix gives the smallest possible rectangle, and each position completely wrong. So always sort the descending with the greater end. So using this greater end, we can just sort the positions in the descending order, including k columns and the minimum height of this column. And people would forget that the array is zero index, and they would use j instead of using j plus 1. So make sure you have to use j plus 1 for the width. So that time we get the correct area of the value we have given. The next one is we have to break when the 0 is comes. So it will not do anything, but it will increase the time complexity. So we have to use it to maintain and reduce the time complexity of this problem. So the next one is people would worry about the column identity after sorting. So students sometimes panic that if I sort each row, how do I know which original column maps to which question? So the answer is you don't need to know. So the problem says we are allowed to rearrange the column in any order, and sorting gives us the optimal arrangement implicitly. So we never need to track the original column indices. So this is the LeetCode 1727. So there are 2 insights and 3 line of 4 logic and 1 elegant solution. So the first insight is we have to transform the array matrix elements and running the consecutive ones counts, and if you see anything we can just change it. So the next insight is that we have to sort each side row from descending, so it will let us greedily find the maximum rectangle. So the kth position in the sorted order, it will give the array of height of k and multiplied by k plus 1. And the time complexity is big O of m multiplied by n, and it is multiplied by log n, and the space is 0 big O of 1. So in place height computations. So descending sort for this with yearly break on 0, and these are the implementation details that we separate a correct solution from a wrong one. So if you like the content, make sure to like the video and subscribe for this daily walkthroughs. So that's all for this today's live. We'll see you in the next slide.